so I have a hook, and two forces are acting on that hook, F1 and F2. Now, what I'm given is I know F1, I know the magnitude of F1 is 300 newtons, and I know the direction angles F1 creates with different axes. I'm already given X, Y, Z here, so I don't need to be worried about that. Right? This is direction of X, this is direction of Y, and this is direction of Z. Now the example goes as, it says we have two forces act on the hook. Obviously, as we can see in the figure. Now it's asking us to specify the magnitude of F2. So I know the magnitude of F1 and the angles it makes with axes. So I want the magnitude of F2 and its coordinates, or coordinate, I would say direction, as the problem says. Direction angles so it's very similar to the example we did for two-dimensional problems, so that the resultant force FR, we call it FR, resultant force. So we're given another piece of information because we don't have enough information to solve the problem. And we are told that what we know is that the resultant force, or FR, acts along the positive y-axis. Acts along the positive y-axis. And, obviously not enough, and has a magnitude of 800 newtons. So this information pretty much is trying to tell us, well, let's say FR, we know FR is in along y direction, so that would be our FR. So this would be my FR. I know its direction and I know its magnitude. So instead of giving the information about F2 so that I can use that with whatever I know about F1 to find FR, or resultant force, just made it a little more, I don't want to say challenging, a little different. We are given information about FR, or resultant force, and we want to find out more, or the magnitude and direction of F2 instead. So I'm going to follow pretty much what we discussed, right? I'm going to say, well, I know these are two vectors in 3 dimensions. You sum them up, you should get the resultant force. So FR is pretty much always true, is equal to sum of F1 and F2. It's F2. So I know a lot about F1. Let me call that 1. Let's talk about F1. So let's find F1. How do we find F1? As a vector, right? I know its magnitude, I know these angles, so I'm just going to use that information. But if you remember when we were talking about vectors in 3D, I pretty much said, well, F1 is the magnitude of F1 cosine theta x in I direction, plus magnitude of F1 cosine theta y in j direction, and plus magnitude of F1 cosine theta z in z direction. Right? Alpha, beta, and gamma, the angles they create. As long as you multiply the magnitude with the cosine of that angle that it creates with that axis, you will get the component in that direction. So let's say I'll take F1 out, and I say cosine 45 degrees plus cosine 60 degrees. I'm just plugging in theta x, theta y, and theta z, And let's not forget ijk. So let's say cosine 45i plus cosine 60j plus cosine 120k. So this gives me f1. I can actually represent f1 as a vector. You do this math. F1 is, the value of f1 is 300 Newton. Right? You can find these cosine values. So from there, you can actually find the vector. So that would be 212.1 I, assuming that I did the math right. 150j minus 150k. So this becomes the vector representation or representation of f1 in Cartesian coordinate. We said we always find the representations in Cartesian and then take it from there. 2, I'll call 2 for f2. We don't really know that much about f2, right? So f2 is pretty much the magnitude of f2, or let me just be even more general. I'll just write it as its components. Would be f2x in I direction plus f2y in j direction plus f2z in k direction. f2x, f2y, f2z, I'm referring to components of f in f2 along these axes. So let's just put everything together. What is fr? Well, before we do that, what is fr as a vector? Can someone tell me that?
It's f1 plus f2.
Well, that is the general representation, but fr itself, we have some information about it, right? We want to represent fr in Cartesian coordinates or xyz coordinates. How do I write it in ijk?
We multiply 800 by each of the angles that are given.
Exactly. If you do that, well, the angles are, if you can see the vector even by looking, the vector is in y direction. Right? We know its magnitude. So it's pretty much just 800j. But you can always do that by multiplying these. You'll get cosine 90 degrees, right? This is pretty much just 800 cosine 90 degrees I plus cosine 0 degrees j plus cosine 90 degrees k. Gives you 800j. But you could also infer that from the information you're given. It's in positive y and has the magnitude of 800. Now that you know all these vectors in Cartesian, you are going to form this equation that you started with, right? This equation there. I'm going to put everything together. Right? It's going to give us enough equation to solve for unknowns. If I put, let's say, 1, 2, and 3 together, I'll get 800j is equal to 212.1 plus f2x I plus 150 plus f2y j plus f2z minus 150k. Right, now looking at this, it's going to give me 3 equations. If I expand it here, looking at components in I direction, there is nothing on the left side, 0. There is 212.1 plus f2x on the right side. So this is 0. From there, you can get f2x. Looking at the components in j direction, well, on the left side, I have 800. On the right side, I have 150 plus f2y. So the only unknown is here is f2y. Looking at components in z direction, nothing on the right side, on the left side. On the right side, I'll get f2z minus 150 is equal to 0. So I get f2z as 150. Previous ones, this becomes 650, and this becomes minus 212.1 Newton. So here are the components of f. Now you can find the magnitude f2. We can find the magnitude of f2, right? f2 magnitude would be the square root of f2x squared plus f2y squared plus f2z squared. If you do that, you have everything you need. You're going to get 700 Newton. Right? This also gives you the magnitude of f2. These are the components. This is the magnitude. And finally, you can find the direction angles. Right? For direction angles, again, theta x or alpha. I think we used theta x before. So let's just call this, talking about these angles. So let's call these theta prime x. Creates, this is actually y. I don't want to make it crowded, but you get the idea. Theta prime x, and this is theta prime z. I'll call this theta prime because I use theta x, theta y, and theta z already. So let's do, it's going to be cosine inverse f2x divided by magnitude of the f2. Theta y would be cosine inverse f2y divided by magnitude of f2. And these are primes. Theta z is equal to cosine inverse f2z divided by magnitude of f2. And you can get the values here. Get 107.64 degrees, 21.79 degrees, 77.62 degrees. These are directional angles that we were asked to find in this problem.